let's go ahead and take a look at standard deviation. So again, just like with the ADM, standard deviation, the idea is we want to describe a typical or standard distance from the mean. And it turns out when it comes to calculus, the formula for ADM actually isn't very pleasant. So in the background behind all the statistics that we'll be using as we go forward in this course, there's actually calculus in the background. We just won't be doing the calculus. So they decided to use a slightly different measure of typical distance than just the average distance from the mean. And that measure is standard deviation. I'm going to write out the formula. We will not be using the formula. We will let Desmos do the work for us in this class. But the formula for standard deviation is the square root of the sum of each data value minus the mean squared divided by the number of data values minus 1. So again, this symbol means the sum of x will run through all the data values. So the sum of, meaning we will do x, a data value minus the mean, square it, and we will do that precise thing for every single data value we have. X bar, once again, is the mean. And n is the number of data values or our sample size. Again, you don't need to worry about doing calculations for this. There is a link from your readings to a video on actually using the formula. We won't need to worry about it for this class. Instead, we will use Desmos to do our calculations. So to do the calculations, all you have to do is enter a data list into Desmos and name the list as we usually do. Then in the next entry box, you will type STDEV for standard deviation, and then in parentheses, put whatever the name of your list was. And then the standard deviation will just appear. So if we go over to Desmos, if we wish to enter in a list, let's put in a capital A, say, and then, whoa. And then equals, and then we need our square brackets. And let's just do 3, 6, 9, 2, 4, 3, 6. Oops. Right, so there's our list. You might have a specific list to put in. I just put in a random one for the moment. And now we put in STDEV for standard deviation. You can also find that under the functions. And then if we go to functions, stats, STDEV is one of those functions in the far right column. Right, if we put that back away, we need our parentheses, and we named our list capital A, and there is our standard deviation already calculated for us. So if we draw our dot plot, of that list, and calculate the mean so we can see where the mean is. We can visualize our mean and standard deviation. So I'm going to draw a line at that mean, and then we can go ahead and denote our standard deviation of 2.4 approximately. So this is at 4.7. If we drop by 2.4, will be sorry about that. I went ahead and added in 2 vertical lines if we did 1 standard deviation to the left of the mean and 1 standard deviation to the right of the mean. You don't need to put in these lines if you don't want to. This is just sort of so we can see what's happening. So notice that we have 5 points inside those lines and only 2 points outside those lines. But that last point on the right is fairly far to the right. Standard deviation puts extra weight on the points that are far from the mean. There's that square in the formula, so it puts a lot of extra weight on the farther points and less weight on the close points. So basically the points that are close to the mean are typical. It's not that surprising that there's some movement left and right. But as the points get further and further away, it gets even more and more and more surprising when we shift just a little bit. So it's pretty common to have most of our points inside the standard deviation and fewer points outside of the standard deviation. So these lines are sort of telling us where our typical points fall. If I go back into our notes, standard deviation, because we do have that extra weight from our squaring, is slightly larger than the ADM typically. Okay. So my pen's not working. One moment. Try again. So standard deviation is essentially just a little bit larger than the ADM, but we can use the ADM as a rough approximation. So standard deviation is a bit larger than the ADM. But we can use ADM as a rough approximation. So basically, in the previous video, we did some practice with estimating ADM and comparing larger versus smaller ADM. The same rules apply for standard deviation. How we use standard deviation, we will have many more uses for standard deviation as we go through this course. But just to start off, standard deviation is a measure of typical distance. So just like with our 5-number summary, the Q1 to Q3 sort of told us what our typical values were. With standard deviation, we consider typical values to be those within 1 standard deviation of the mean. So what I mean by that is if we have our number line, and let's say that our mean falls right here, and then if our standard deviation, whatever value it is, if we add on a copy of our standard deviation going to the right, and we subtract off a copy of our standard deviation going to the left, then basically we consider anything between those values to be typical. So if we draw dashed lines at those points, then anything in between is considered to be our typical, and things on the outside are not as typical. So this is our typical. Right, so that's sort of our general idea behind standard deviation. We will go way more in depth as the semester goes on.